Okay. Yep, we'll go ahead and get started. As you just heard there, we are recording this session. Want to thank everybody for joining us for our December technical program for the ISA New Orleans section. Today's topic is going to be around cybersecurity and cybersecurity risk assessment, and we'll introduce our guest speaker in just a moment. So let me get the screen active here. There's a couple quick introduction slides just to kind of let us know what's going on in the section. This is December, the end of the calendar year, but we're just kind of in the middle of our program year. So we go from July to June. So we still got another 6 months or so of stuff coming up here in 2024 for this particular term. So we invite you to stay up to date with us. Our section's website, our social platforms, and ISA Connect, of course, is really the ultimate place to go and stay up to date on what's going on. So if you were with us last month in November, we had a program in November, first one we had in quite some time, admittedly, and we had made a mention that the New Orleans section had been listed as not in good standing. Basically, we didn't quite do 3 member meetings in our 2022-2023 program year, and we needed a treasurer. We had a treasurer, and that person decided to not want to do the role any longer. So here we are in December. We want to first thank Jose Suarez for volunteering to fill our treasurer role. So that's going to definitely get us back into compliance with ISA society. And as we just mentioned, we're halfway through our program term, and we've already done two of the 3 required section events. So we'll be back in compliance there too. So we're back on track. So just look forward to information coming up for 2024. We'll have some topics identified. Hopefully we'll get one in January, and then continue to do this throughout 2024. One last reminder too, we mentioned this last month, and that is, if you haven't seen this, or if you've kind of been forgetting to do it, the ISA Society has transitioned the membership to a calendar year renewal. So everybody would have gotten a prorated invoice to basically take their membership through the end of next December 31st, 2024. So those prorated invoices had gone out several months ago. So if you kind of forgot about that and you haven't paid that invoice yet, you still got a couple of weeks to do so before the end of the year. And then once you do that, you'll be paid up through the entire 2024 calendar year, and you'll just need to renew before the end of next year. If you have any questions on that, reach out to us. Also, there's information on ISA's website about that conversion to the calendar year membership. And with that, just want to introduce our topic and our presenter. We're very fortunate to have Schneider Electric volunteer to present for us today. Cybersecurity risk assessment, and Nash Johnson, who really was instrumental in helping get this set up with Farshad. Can't make it today, unfortunately, but we got Farshad Hindi, cybersecurity business consultant with Schneider Electric, who will kind of take the presentation from here. So Farshad, I'll stop sharing.
Thank you very much, Wayne, and I am sharing my screen. Okay, share. Hopefully you can see my screen.
Yep, we're all good.
Okay, wonderful. Thank you very much. I hope that everybody are in good health and enjoy the good weather right now. I guess it's good weather in the Baton Rouge and Louisiana.
Yes.
Again, it's definitely favorite state for me to visit. I'm now living in New Jersey, in the Princeton, New Jersey, but I used to be in Houston. And again, I use any excuses to come to Louisiana. I love the food there, love the people. Thank you very much to give me this opportunity. today we are going to talk a little bit about cybersecurity lifecycle. As you saw, that the title was cybersecurity risk assessment, and you may heard we have so many assessment in the cybersecurity. Sometimes we getting confused. What's going on? Is it a gap assessment or compliance assessments, or now this one is risk assessment. I will kind of hopefully after this presentation, you will get a good understanding of what we call it the risk assessment in the cybersecurity. But to do that, I will start with the safety lifecycle. I'll talk a little bit about the risk, and then talk about two assessment that we have in the cybersecurity as per the IEC 62443, high level and detail level. And of course, I will present the basics and what is mentioned in the standard, but I share some of the real world experiences that we have when we go to the our end users and started doing assessments. That it is kind of hopefully that would be helpful for you. Then I will kind of also wrap up with some definition maturity level, and finally with security program rating, because the goal for assessment is really to understand, to qualify the operation and understand that how much it's capable and how much risk they can tolerate. And this maturity level and security program rating is the result of that risk assessment that I try to kind of wrap up with that one. Again, my colleague, unfortunately, Nash, engaged with some activities that he couldn't join. He is local to you. If for any reason you needed any kind of a follow-up, he is reside in the Baton Rouge, and he's our client sales executive. He can definitely will be in touch with you. As you can see, it is his LinkedIn. Please, kind of join him, and if you need anything, please kind of contact him. This is me. I'm not as handsome as Nash, or also not as young as him. I'm working in the industry for about 28 years. And majority of that was I started with as an instrument engineer, then automation, then function safety and cybersecurity. Right now, I have several certifications, among them, cybersecurity response and industrial defense certification. I am the functional safety expert by TÜV Rheinland, and also I have the CFSE, that it is governed by the EXIDA. I'm sitting in several of those standard committees. I'm a part of the IEC 62443, IEC 61511, ISA 84, and NFPA 85. All that the latest ones are. I'm the principal member and voting member on those. Okay, with that, let me also give a very high level, very short 1 minute kind of introduction about the Schneider Electric. I'm part of this, again, gigantic company that it is global in reality, but we are try to be kind of present in local and work with our clients and end users. We, as a cybersecurity, we are kind of having 6 regional hubs across the board. One of them is in the Houston, not very far from you, but we have a big office also in Baton Rouge that serve our clients. So we have several cybersecurity consultants and lots of field service engineers that already kind of able to provide those services to you. And then those people are certified with the latest and greatest in the standard committees, and also in the certification bodies. And we try to provide the services. And one of the important things that I want to add here is that our team of the cybersecurity team is vendor agnostic. While we love you guys have kind of carry our automation services as automation kind of platforms, but our services is kind of independent from them, and we are able to provide the services regardless of what systems you are having. Okay, now let's focus on the topic. Because we are talking about risk, it is natural that we all kind of think about the safety and cybersecurity together, right? Because you cannot manage the risk in isolation. You need to kind of manage the risk while for the safety and cybersecurity together, because cyber is affecting the safety, and safety may kind of impacted by the cyber. This is why there is a kind of a good inclination in the end user community that people are looking at the safety and cybersecurity together, especially when we are talking about cybersecurity in the operational technology OT side. Yeah, that is kind of a natural complement to each other when we are kind of look at these two together. In the recent years, we have I was part of a group of the working group under the ISA 84 called Working Group 9 that released so far 2 versions of the technical report 840009. And the idea was that, they are kind of presenting and providing the standard for the cybersecurity around the safety systems, because the safety system in a sense is a very critical kind of a system, is an essential system, part of normally a crown jewels of your operation if your operation is critical. And then compromising of that safety system will have a big impact that normally is the higher impact than other systems. And it is why focusing on that one and providing the system kind of a cybersecurity provision for that is very kind of makes sense, because if you provide that and then go with other systems and make it consistent across your operation, you will ensure that you cover everything and nothing will be left out. Anyway, to do that, this standard technical report kind of suggested a combination of those life cycles between the cybersecurity and process. And as you can see, the nice thing is that they are very parallel and kind of aligned together. Of course, when we start to do the analysis, we need to understand the risk and understand the hazard, around our operation. And that could be for safety and could function safety hazards and also cyber hazard. And it is again that we are able to do this kind of activities together, those assessment, or we can do it separately. And then when we are having the system, when we identify the hazard and we identify the controls and countermeasures and barriers, depending which side of the kind of fence you are talking about, then we are starting to design the system accordingly. And then when we have the systems, we are having some guidance for operate and maintain of each of those systems. But as I told you, and it is kind of, hopefully it is clear for you guys that these two kind of disciplines needs to work together and collaborate with each other. The nice thing is that if you think about the outside of this ISA and IEC kind of realm, and look at what we have as a guidance and regulatory guidance for the North America NIST, that is also aligned with these two life cycle. It means that the idea of identify the problems and the crown jewels and the systems, then finding the protections and through the detections and some respond if it is something happened, and then go to the recovery cycle. It is kind of having the same idea of the identifying the risk and then do the design and then go to the operate and maintain and try to kind of detect, respond, and recover when something happening, right? With that, let me just change a little bit the gear. Let's see what we are calling risk in general and what is the differences, the risk that now that we said that these two discipline can work together and can be aligned with each other, what are the differences? When we talk about the functional safety risk, and normally what some of you that are working for end users maybe participate in HAZOPs and low pause and risk assessment process hazard analysis, the risk that we are talking there is very probabilistics. A portion of that is also non-probabilistics, because the risk when we in the safety side is when your systems are fail. When your kind of your DCS, your safety systems, your instrumentation fail, that the behavior of this failure is mostly probabilistics. Or when your humans involved on that process, like operators and maintenance team, do mistakes, that portion is non-probabilistics. Yeah, that is two portion of that risk that we have. And in majority of time, the risk that we have caused by it is not intentional. Yeah, it is caused by, even if it is because of the human, it's because of the mistakes or error that happened by humans, right? And then for qualification and kind of measuring that risk, we are able to provide now have a good methodologies that able to identify the risk quantitatively and also qualitatively. In this case, risk is impact multiplies likelihood. What is the highest impact that can happen because of a failure of your these instruments, and then how frequently that happen, and these two together give us the risk. In the cyber side, the risk is normally non-probabilistic because it is caused by the humans. It's mostly it is intentional. And in that case, as I told you, we could kind of model the risk in the safety side, because the failures normally is type of a failure model are static. But in the cyber side, we have the risk is very dynamic, because you have systems that there are some vulnerabilities on them, that it is every day it's explored, come, and it can be kind of exploited, and that is kind of the thing that we give it a dynamic behavior. In this case, again, we have the risk can be defined as impact, and then likelihood can be divided to threat, that it is coming from external normally, and the vulnerabilities, that it is part of your system, your process, your operations, that holds that it is existing in your system, operation, and also systems, that can be exploited by the external threats. That could be, again, that threats, external or internal threats, could be internal kind of people exploit that kind of vulnerabilities, or external people exploit that vulnerabilities and cause the damage. Yep, that is the difference. Now, with this kind of introduction, now let me go and look at the standards and see that what are the recommendations for doing the risk assessment in the Technical Report 84009 and IEC 62443 section 3.2. Yeah. The difference between two is that in the left side that you see the Technical Report 84, we have a integrated functional safety and cybersecurity lifecycle. In the right side, that it is 62443, is pure kind of cybersecurity lifecycle. As you can see, the nice part is that from the risk assessment point of view, these two are very aligned. We have both of them recommended that if you want to do the risk assessment, you may need to do an initial cybersecurity and risk assessment to give a kind of high level measures that you can design your system based on that. And then when you identify your system is already, what's going on with your systems, and you have some good kind of documentation about your system, then you can go and do the detailed cybersecurity risk assessment. And I kind of explain why this approach is kind of efficient and it is kind of working. Okay, when we do want to do the risk assessment, of course, one of the important, as I told you, the first step is to identify the impact. And when we want to do the impact, normally we separate the impact analysis from the likelihood analysis. And when we do this kind of impact analysis, you are looking at the operation and look at what could goes wrong, and based on that, how things can go wrong. Do the hazard identification. Those are potentials that if goes wrong, that cause some damages and cause some impacts. Okay, normally we are looking at the system, see that what is the, how things can be, any deviation can cause the explosion, maybe fire, some toxic material release. And I'm talking again, focusing in the OT side, loss of production, some environmental damage, some community, impact, and some data breaches from the, again, IP, and also the, those type of information that can be cause some damages. You focus on any of those hazards, and then identify that if any of those happening, how this impact your assets, that mostly are people, your operations, your equipment, that it is IT and OT now, your environment, and again, community, and the reputation of your company. And then those again go, the next step is that think about now the impacts. If this happen, if this explosion happen, how people will be injured or maybe have, God forbid, fatalities. You know, if this happen, you have some data breach or loss of production, how that impact the financial loss for and business interruption for your operation, how that is maybe caused property damage, some environmental contaminations, you know, community level disasters, loss of customers, loss of IPs, all those things need to identify. And again, we have two options in this case. After your impact is identified, you are able to have some goals for your these impacts and risk kind of categories for these impacts, and you analyze the risk in any of those individual kind of categories and classes. Or you are able to maybe convert all of that to some financial measures and kind of talk about dollar and cents. Normally, if you think about the insurance companies, they are not thinking about the fatalities and, you know, asset that mechanical damage separately. When they are come and insure you, they are looking at all those things, convert everything to dollar and cents. This is a little bit kind of a not very thinking about is not very nice to convert, for example, injuries to financial things. But anyway, it is what is happening. You know, they are converting everything to financial and then telling you that what would be your premium to need to be paid every year to insure you against those risks. Right, but in the normal, in the OT side, in the, you know, the process industry that I'm familiar, people are trying to keep the classes separate. You know, for example, you have classes for injuries, you have classes for the environmental damage, you have classes for the mechanical damages, and separately kind of classify your risk on those classes. It means that you have a risk tolerance risk for any of those categories. Okay, then the first thing, back to the square one. We said that we want to identify the risk. The first step is to identify the impact, and this impact could be in different categories. Okay, now you already identified the impacts. Now you want to do the initial or high-level risk assessment. What you need to do normally, and again, I'm talking about cybersecurity risk assessment here. Normally, you need to have some guidance from your process management, process safety management team to give you some, again, already done HAZOPs, low pause PHAs in general. Give you, okay, this is what we have done previously, and we have these scenarios available to you. If not, you need to do that, because that is the first step, to identify the scenarios, how things can go wrong, and if that goes wrong, what would be the impact of that. Okay, that is available as input. Second thing is that you need to identify, do you have the asset inventory? What is part of your OT, you know, in kind of systems? Well, is this switch is part of that? Is this computer is part of that? This server is part of that? You need to have a good understanding about your asset. And normally we recommend that you need to have a proper asset inventory. And reason for that is that, again, lots of you heard about the concept of the air gap. Lots of people says, okay, my system is air gap, is not connected to here, not connected to there, and it is isolated. I don't need to have any type of cybersecurity provisions. You know, this asset inventory help you to understand the connectivities. It can help you to understand if this portion that even is air gapped, you know, if it is compromised, how it is impacting the overall operation and how it's impacting the overall risk of your operation. Okay, that's the second thing that needs to be ready. The third is risk criteria. Some of the things that I will kind of talk about is some of the things that is normally is not very clear. How much risk an operation can tolerate? And that's the baseline for starting any activities. How many injuries per year this operation can have? You know, I have a chemical operation, and then I want to know that this operation, how many injuries per year I may have. Yeah, or how many fatality, God forbid, maybe we can have, or how many damage you can have, how many financial damage you may kind of able to tolerate. Yeah, that is the first step. That is your tolerance level. And your idea is to reduce the current risk, the existing risk, to the level that can be tolerated. If you look at some of the measures, some of the numbers, normally, again, for the fatality is normally 1 fatality per million years of operation. Yeah, it is. Then if you have some fatalities, in your kind of operation, or some injuries in your operation, more than 1 per million years, then you need to reduce your risk to that level that is tolerable. Again, in some countries, those numbers are kind of identified by the regulators, by the governments. But here in the US, we don't have it. We normally, it is up to the companies to identify that one. But that needs to be identified and needs to be documented and needs to be kind of presented to regulators if it is the system is audited. Okay, of course, we need to have a cybersecurity risk assessment team to do that. And normally we need to have the system architecture to do this risk assessment. With all those inputs, we are putting together a team that go through the scenarios, one by one, and then identify that what is the worst case scenario that can happen if any of our systems are compromised. Again, in this case, at the high level risk assessment, normally what we do is that we identify the likelihood 1. It means that you assume that if there's a vulnerabilities, if there is a kind of a definitely that will be exploited, right? In this case, we assume that this always will happen. Then you are assumed that we don't give any kind of discount because of the likelihood of events. We said that event is definitely happening. Now let's look at the system and see that if this happened, what would be the highest, worst case scenario impact? And based on that, we identify that, okay, how much risk we have, right? And then one of the things that we are doing here is to group things together based on the current risk that they have, based on the controls that they have, based on the current risk that they have, we group them together. And it is what we call it the security level. Okay, we call it, okay, this system A and system B, it seems that based on the kind of exploitability and the risk that each one can kind of cause for the operation, they are in the same level. And then we put them as a one group, we call it a zone, and give them a security level that, okay, how much security level you need to have for this zone, how much you need to reduce, how many countermeasures, how many controls you need to put for this group of the systems to reach the tolerable risk that we mentioned, right? Of course, after that, we are started to document the information. Output of this process would be a revised asset inventory, because we are going now to a detail of analysis of the kind of systems. Normally, we identify some better output as asset inventory that we normally revise the asset inventory. One of the output of this process is the zone and conduit diagrams that I will show it shortly. As I told you, grouping of the systems that kind of connected together and how they are, each group can be communicating to other groups. And then some data flow diagrams, because we have the system architecture now, we show it that easily also that how data from one point of kind of our overall system move to another point of the system. Is it OT, is it IT, how they are kind of transfer the data, how they are kind of isolate the data. And again, that would be the input for the next step that we want to do the risk assessment. Hopefully that was clear. Again, I want to summarize one more time very quickly. You have the impact. Now to also assume that the likelihood is also kind of is 100%. Now, based on that, you are going to different scenarios and identify that what would be the risk of the this exploitability, what would be the impact, and then how they are kind of able to group the systems together. Okay, in this step, again, if you look at the guidelines that the standard provided, you may be able to do the kind of go forward and doing this type of risk assessment. The challenge is that when we come to the reality, if we come to the world, we see that the talking is easier than doing the things. One of the challenges that we have is that when we go and try to do this type of cybersecurity risk assessment, we are engaged with the cybersecurity OT team that's most of the time, 9 out of 10, they don't know anything about the PSM, nothing about the process hazard analysis. and they've not been involved on those type of processes. Then they don't know exactly what is the risk, tolerable risk. Never heard about it. That is a kind of education that needs to be done, and we kind of communications that we need to done. We need to involve the bigger team, bring some people from your PSM team, from PHA, to identify those informations. Again, another very important kind of a common problem that we see is lack of the asset inventory. The system was built 20 years ago. There was some documentation, but nothing updated. We updated our system servers multiple times. Nothing is updated as a complete end-to-end asset inventory. This is another thing that normally it's kind of a hindering our job, and we need to do this one first before we do the risk assessment. Then system architecture, same. Yeah, it is again, system architecture is either old or it's not complete. And tolerable risk, because the PSM team are not involved, tolerable risk also is not in kind of identified. Another big problem is the kind of a concept of greenfield and brownfield. Again, all those things that it is in the standard, it is considered that you are starting from page of paper, and everything is changeable, and everything can be implemented as it is going. But in reality, we are having an operation that is working multi-years. Yeah, you have a brownfield, and it's not easy to change the system already. Because again, even cybersecurity, earlier days, what we have done was based on some kind of a prescriptive recommendations. We put firewalls here, we put switches here, we put maybe DMZ here, but we really didn't know why. We just followed the guidelines, and we thought that, okay, it is definitely would be good. Now we are doing a risk assessment. We identified that not necessarily everything that we did was right. Now you need to change your zones here or there, and that is a big problem, right? Because already it's established, right? That is another challenges that normally we have after we do this risk assessment and we got that information provided. In some cases, end user telling us that, okay, considering the likelihood of 1, it means that you are always under attack. Everything can happen right now. Everything is available. It's a little bit, it's too much conservative numbers. And they asking us that, put some other factors instead of 100% likelihood. You start with 60%, 50%. And based on that, you go forward and then do your risk assessment. And then when you do the detailed risk assessment and you go and exactly identify this likelihood, then it would be kind of a less kind of a difference between the reality and what we assume at the first place. And it's not that much conservative. We understand that lots of time, again, if our client has some recommendation, we follow that one too as a likelihood at the high level risk assessment. As I told you, one of the output of this assessment would be the grouping, right? It is what we call it zones and the conduits. Normally, this grouping is based on the criticality of the devices that are connected, and then kind of the controls that you need to put in place to keep those systems, again, safe and secure, and you are able to provide those tolerable risk. A system like a safety system that, as I told you, is the crown jewel of your operation, need to be more isolated compared to a systems like your supervisory control that maybe it is if you lose it, maybe it does not have that high impact like your safety system. You are able to separate those zones from each other. Then you put those conduits, and if you want to go go from one zone to another, how you need to send it, what provisions you need to be put in place, and what direction you need to consider for the communication. All those things normally identified at this level. Okay, with that, we are reaching the point that needs to now go and do some detailed risk analysis. Yeah, you already have a good kind of understanding what are your zones, what are your even the security level. One of the things that it's important when you talk about zone, the security level also is associated with your zone is identified. You're telling me that how much security level you need to have for this space. Yeah. And I will talk about security level, in details, because security level has two sides. One is the requirements, how much required the risk reduction, and how much you can achieve. It means that the systems, that controls that you put in place, how much they can kind of give you the security level. Then look at the security level as a two side of a same coin. Okay, when we want to go to the detailed risk assessment, now we are going to identify the likelihood. Again, you remember the risk is impact, likelihood, and likelihood in the cyber risk is now, if you want to identify that, you need to identify the threats, the external and internal threats. What is the response? What's the possibility somebody come and look at your systems? And then the vulnerabilities. What are the kind of holes in your system? What are the gaps in your system that can be exploited, right? And to do that, of course, we need to have a very kind of systematic way to kind of look at this too. Like we are doing the risk assessment to make it systematic, to ensure that we are not missing anything. For vulnerabilities, we have a really good guidelines in the NIST 800-82 that kind of give you how to identify the vulnerabilities. There are lots of databases available right now that any kind of used vulnerabilities and identified vulnerabilities also is listed there. There are lots of tools that give you those information real time to you. Okay, for example, if you have DCS here, if you have a safety system, you have a workstation, any system that you have, if there is any vulnerabilities identified, those are listed there. And then you know that, of course, how you need to avoid those vulnerabilities. Normally, it is through the patching and kind of upgrading your softwares or hardwares, you are reaching the points to avoid those vulnerabilities, close those gaps, right? And those are also, at least you know that something that previously identified is not in your system. And then we also look at the threats. We are modeling the kind of the threats. If we see that there are some kind of movement in some of those groups or teams that have a malicious kind of idea to come and kind of exploit your system or change your system and penetrate your system, we are kind of identify those, model them, and based on the activities that we are kind of monitoring globally, you are able to kind of come up with some numbers about those threats that are available to you and as a specific operation. And then you have vulnerabilities, and based on these two, we come up with some likelihood number. Again, I'm talking about numbers, but I want to tell you that most of the time, right now, these numbers are very qualitative. It's coming from some qualitative kind of overall high level kind of understanding, as we are not yet to the point that you are able to give me with the 3 points after digit, you give me what would be the the likelihood for this system or that system. It is still, we are not there, but there are lots of kind of activities to run right now, is lots of methodologies kind of proposed to give us these quantitative numbers for the likelihood of the system. And when you have those kind of identified, again, you are verified already your information that you had in the high level risk assessment. One more time, you get this information, combine them, and then you come up with the better numbers for your security level numbers, and you may refine your zones and conduit, accordingly. You are able to look at your risk as, again, another number, and compare it with your tolerable risk, and come up that if it is kind of what you already have is sufficient, or you need to add some cybersecurity countermeasures, to improve your security to the level that it is acceptable to you. It's very similar to what we mentioned previously. As I told you, in this case, we are calculating the likelihood instead of getting that likelihood of 1 or 60% or whatever. We go get the information and we go do that another layers of the kind of the risk assessment done in the detailed assessment. Why we do it in 2 level? Because again, lots of time when we do the high level risk assessment, you still don't have that boundaries identified. You don't have that, even sometimes if in the sense of the greenfield projects, you don't have those information for your system detailed and for provisions detailed that you are able to use them for calculating the your likelihood. In this case, we are going step by step, and in detail, we are able to kind of go a little bit further and identify those information and refine it. As I told you, one of the output of this risk assessment now is the security levels. And security levels, originally when it came in the IEC 62443, it came from the exploitation type of point of view. Okay, how much your system can be exploited, or who can come and exploit, come and penetrate to your system? Is it a normal high school student, or is a government that behind it that coming and has a lots of capabilities to do and kind of penetrate to your system? Based on that, they identify the security levels. Now that we have a better approach for doing this, and we have a methodology to doing that, the security level divided to three portions, three kind of tiers, or three kind of types. Maybe it's better to say three types. We have, first of all, we have security level target. What is the requirements for my operation? That is directly connected to your tolerable risk. How much risk you can tolerate, what you have in place, how they are connected together. We do the studies, you get the target, how much the security level you need to have for this specific zone. Do I need any extra kind of provisions or not? Do I need to have firewall? Do I need to have a data diode? Do I need to have kind of access control for this specific system or not? All those things give you the requirements for the targets, what is needed. Next kind of type is what you can achieve with all the systems that you have in place. Yeah, and to see that then between the target and achieved, you may see some gaps, right? That it is the kind of give you the next step, what you need to do to reach the level that you needed. And of course, the capabilities. Your capabilities is what you have, but you may not able to necessarily achieve what you needed, right? Some of the system for some reason doesn't work, and your capability can be realized as what you achieved. Again, to make it more sensible, to make it more actionable, this security level is divided to and kind of identify for 7 what we call fundamental requirements. It's not only one number. It is, as you can see here in the example, we can tell when we are identify the security level target, for example, for your BPCS zone, we said that the SL target for you is 2201313, and that is saying that you need to meet these requirements that you see here, and I kind of explained what are those. You meet these requirements with these capabilities or with these targets. Okay, let's now look at this requirement. What's IAC? What's UC, SI, DC, RDF, TRE, and RA? These are requirements that came defined the 62443 again, part 1.1. And ISC, these are called foundational kind of requirements. The ISC is identification and authentication control. UC is use control. SI is system integrity. Data confidentiality is DC. Restricted data flow RDF. Timely response to events is TRE, and resource availability. As you can see, all those things can be kind of different facets of your cybersecurity operations. It's telling you that, and based on the connectivity, based on the kind of criticality of your systems, we are telling you that what should be the target for your identification and authentication control. Should all of our systems have similar IAC? Not necessarily. We don't want to protect systems that are not needed. What is the use control? What is the system integrity? For example, again, if the integrity of one of your systems, like safety system, is changed, that can have a big impact for you. Not necessarily for all your system, you have the same kind of requirements. And same for other things. We are going to identify different facets of your zone, that zone of under study, and give you a kind of requirements that what you need to put in place. Same for other side of the coin. When we want to analyze that how much you can achieve or how much capability you have, we are looking at all those 7 items and look at and can telling you that, okay, for example, you may able to, you are good in the IAC and UC, but not necessarily in the, response, for example, if it's something happened. And that is where kind of you need to decide that how you are able to kind of provide the protection for those areas of the discussions. Again, as you can see, it's very actionable. You are able to exactly understand what you need to do. And of course, based on that, you are able to come up with some assessment, right? When you want to do the compliance assessment for your, we have done the risk assessment, after you identify what you have, now we are able to look at your kind of operation and says, okay, if you want to get security level 1, based on what you have right now, and you are able to get only security level 1, because you are not having, for example, the human user identification and authentication, or you don't have the, the multi-factors, then you are not able to meet the security level 3 or 4, because it is mandatory for this kind of identification. It is kind of you are able to assess yourself where you are standing right now based on the requirements that we identified, right? It's kind of the other side of coin that I was talking about. Of course, again, coming to the reality, we see that there are some challenges. First of all, because all those several independent controls we said, FR, it's challenging again to come up with some. People are getting confused that, okay, now what I need to do, is it security level 1? Am I security level 1, security level 2, 3? How I need to coherently make it security level 1, or level 2 or 3. That is kind of what we see the challenges to kind of realize and comprehend this different kind of criteria to achieve. As I told you, right now, lots of those numbers are still qualitative. Again, we don't have some good quantitative methodologies to give you exact numbers, and that is make things a little bit subjective, right? If kind of a facilitator number 1 coming, they may come with some numbers to you, and then you change the team, somebody else coming, you get the different type of kind of results, and that is sometimes frustrating, because again, lots of times is the information would be subjective. And again, sometimes there are so many kind of devices that if you want to go to all of those and do the detailed kind of risk assessment, it become costly, it become too much of the efforts. In this case, one of the things that normally we provide, instead of going to the asset-based risk assessment, we come to the zone-based risk assessment, right? We assume that what you have done in fine, and your kind of your zones are properly kind of identified. And then when we do the detail, we are looking at the zone level, not the asset level. And one zone, maybe there are multiple systems there, reduce the effort and make it a more cost effectively. You can always go back and kind of for those high critical kind of zones, you do asset-based risk assessment, but you can start with the zone risk assessment at the first step. Okay, I'm done with my risk assessment up to this level. You already have the security level identified. You already have you have a good guidelines and measures that identify your security levels. As much as we went and identify all those fundamental and foundational requirements, most of those was towards the technical kind of part of the cybersecurity. Okay, do I have this device here? How my communication is working here? All is based on the technical aspects of the cybersecurity. But as cybersecurity, unfortunately or fortunately, has a big portion of that is the management, is the process, how we are running the systems, and because of that, again, standards now recommending to you that while you are focusing on bringing that security levels, think about also the maturity level. A maturity level is the management type and process type of activities that is talking about actions and system and again process systems that help you to run this, keep the system secure, right? Something like a training, something like kind of a hierarchy in the system, or something is like having some procedures that is already available that can be done. Based on that, as you can see, we have another 4 level of the kind of maturity defined for the management kind of system that we have, and we can be evaluated between the initial, manage, define, and optimize. And as you can see, it has its own definition, has its own guideline, how we are able to assess it. And there are definitely a very established process for doing that, right? It means that somebody can come, or you internally can review your management kind of systems and come up with some kind of level for your maturity level. Okay, then we have technical in one side, and we have the managerial in another side, maturity level and security level. And again, now makes sense to combine these two together, right? Instead of only purely we are focusing on the technical or purely thinking about the managerial type of maturity, standards recommend that think about combination of these two. If you really have a critical systems and you want to ensure that it is immune against any type of kind of penetrations or kind of exploitations internally, externally, you need to have what we call it a security program rating number 4. It means that now not only your security level, your technical measures needs to be high, also your managerial level and your kind of your maturity level also need to be high. And combination of these two can give you the level that what we call it again security program or security protection rating that kind of enable you to give you some confidence that I'm able to protect my operations against any level of the exploitation, even with the highest, with not only help me to avoid my high school kid kind of come and hack me. Not only that, it is also helped me to protect me against those professional kind of people that come and ransom takers that come and wants to kind of penetrate your system and take some ransom from you because they are living out of that. They are very professional for doing that. Anyway, this is the latest kind of progress that we had, that now we are measuring things based on the security program, that it is the combination of the technical and managerial. That was, I guess, with that, it was what I wanted to present. Just before we maybe open for a few questions, if there is a question, I just want to conclude this presentation with again what we have started. We definitely are. If you need some help, we are able to help you in the Schneider Electric, and you can get the help again from anywhere else. But ensure that when you get the help, you get the help for the entirety of your kind of program. Yeah, the security is something that you need to consider it holistically, and you need to ensure that you go systematically identify the risk, identify what you need to have in place as a countermeasures and systems, and then maintain it. And again, in the Schneider Electric, we are able to help you in any of those steps that you are. If you are started or you are already have a very mature system and you want to optimize. That was what we covered. And again, sorry I talked a lot. I'm getting passionate about the subject, and sometimes I cannot help myself. Yeah.
No, thank you for. I'm going to go ahead and stop the recording so we can feel free to